welcome to What's Up Over Edmonton for the month of June 2022. My name is Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada Edmonton Centre. We have the picture of the Queen Elizabeth Planetarium because that was the original plan, to hold these sessions in there live. But with the pandemic, we've been doing it online on Zoom since the beginning. But someday we hope to go live into the QEP, but we'll also continue on Zoom. Call this What's Up Over Edmonton because the skies over Edmonton, where we live at 53 degrees north latitude, are quite a bit different than those represented in many popular astronomy publications like Sky News, Astronomy, Sky and Telescope. They're more typical for the mid-latitudes of the United States, or in the case of Sky News, for Toronto. And as an example, this is the sky over Toronto on July the 5th at 11 o'clock. And this constellation here, Scorpio, one of the few zodiac constellations that actually looks like what it's supposed to be, is completely above the horizon. Yet in Edmonton, this is all we see. We see the top, and about halfway through the bottom. We never get to see the tail or the stinger of Scorpio here in Edmonton. Most of the information I use comes out of the Observer's Handbook, which is put out every year by the RASC. It is 352 pages of all sorts of information that the astronomer, both amateur and professional, can use in their observation programs. Also use some information out of publications like Sky News and Astronomy. So what do we got in the sky in June 2022? School's out for the summer. Not a lot's going on. We have the longest of days, the shortest of nights. We have a full moon that rides low across the southern sky. And that full moon is at perigee. And as we get closer to the day of the full moon, which is the 14th, we'll hear talk once again that it is a super moon. The sunrise today was at 5:11. It will set at 9:53. There is no night. We're in perpetual twilight. We also have the summer solstice, the longest daylight hours of the year, on the 21st of June. And on that day, the sun will come up at 5:04 and set at 10:07. On the 30th of June, the days are already starting to shorten somewhat. Sun rises at 5:08 and sets at 10:06. Okay, this is the planetarium portion, which, as I have been doing for this past several months, have pre-recorded. So we'll start that. Okay, we'll start our planetarium portion here, and it's June the 1st, it's 9 o'clock, and we're just going to watch the sun set here. And it, as you have probably noticed, the sun has moved further to the north as the weeks have gone by as we approach the summer solstice. So I've made the time 11:30 on today for June the 1st, and let's look at the evening planets. Well, look at that. There aren't any. There are no planets in the evening sky at all. There is a thin crescent moon. It's almost 3 days old. But other than that, there is nothing from our solar system in the evening sky. If you want to see planets, you got to get up early in the morning because they are all in the morning sky, starting with the earliest riser of Saturn, followed by Neptune, a telescopic object, Jupiter, Mars, Venus, and another telescopic object, or steadily held binoculars, Uranus.
all in the morning sky. At the beginning of the month, Saturn is the first to rise. Tonight, it'll rise about 2 in the morning. By the end of the month, it'll be rising at just after midnight. Neptune is next. At the beginning of the month, it's rising at 2:50. By the end of the month, it's rising at 1 o'clock. Jupiter is rising at 3 o'clock in the morning and rising at 1:15 at the end of the month. At the beginning of the month, Mars comes up just a little bit behind Jupiter, around 3:15. At the end of the month, it's coming up at 1:50. Uranus, 4:15 when it rises. By the end of the month, it's coming up at 2:20. And Venus is rising at 4 o'clock in the morning. By the end of the month, it's coming up at 3:30. Venus will be pretty much in twilight because the sun is coming up fairly early. And Mercury will join the parade at the end of the month, coming up around 4 o'clock. So let's just watch this parade of planets. I've set the date for the middle of the month, June the 15th. And we're going to start at 1 o'clock in the morning. And here we can watch the planets rising. There's Saturn, first out of the gate. Next time comes Neptune, which you need a telescope to see. Then Jupiter, followed by Mars. Mars is getting brighter every month. It will be extremely bright at the end of the year. Shift over a little bit here. Uranus, and Venus. It's 4:30 in the morning now. The sun is coming up. There's Mercury, but it'd be pretty low, pretty tough to see middle of the month. And here we have the sun coming up over the horizon. Going back to 4:30 in the morning on June the 2nd, tomorrow morning. If we just watch the planets as they move throughout the month, advancing a day at a time, you can see Saturn is getting higher and higher, as is Neptune and Jupiter. So they get to be easier to see. I wouldn't recommend getting up at 4:30 to see them because the sky is already starting to brighten. But if you got up at say 3 in the morning when the sky is darker, of course at this time of year the sky never gets completely dark, and with a pair of binoculars you should be able to easily see Neptune because it's fairly high up. And Saturn, and in a telescope, of course, Saturn looks spectacular with its rings. The moon enters the picture on the 18th. It's below Saturn. And on the 20th, it's near Neptune. On the 21st, the solstice, it's just below and to the right of Jupiter, swinging past Mars on the 22nd and 23rd. And we'll just move that over a little bit here. On the 24th, it's near Uranus. And on the 26th, it is near Venus. As we carry on through the month, 27th, it's near Mercury, but Mercury is a fairly tough target because it's so close to sunrise. It'll probably be lost in the glare of the oncoming dawn. And then on the 29th, the moon is out of the picture. That's also when we're going to do our next What's Up, just because of the way the dates work out, and there is 5 Wednesdays in June, so we're going to do the next What's Up on June the 29th. Now we do have a comet in the sky. I think I talked about this last month. Well, I talked about 2 comets last month. This one is comet Pan-STARRS C 2017 K2. The other comet I talked about was Pan-STARRS C 2021 C3, which at the time I made the recording, which was almost 10 days before What's Up, was looking very promising, but it turned out it disintegrated and turned into a dud. So anyway, Pan-STARRS C 2017 K2 will not be a dud, but it will not be visible to the naked eye either. And it's a telescopic object. It's about 7th magnitude, and through the month of June it's going to be going through Ophiuchus. So there, we'll center Ophiuchus there in the southeast sky, set for 11:30. And if we just advance through the month, you can see the comet moving into Ophiuchus. And here we are, July 1st. And by the end of the month, it's well within the boundaries of Ophiuchus in the southeast sky. So if you have a small telescope, you should be able to see it. There will be finder charts you can get off of Heavens Above, or if you pick up the June issue of Astronomy Magazine, there's a finder chart in there also. In terms of deep sky observing, June and July are not really the best times for deep sky observing in Edmonton, just because of perpetual twilight. In the south, that's probably your best bet. The sky is a little bit darker in the south than it is in the north here. There are a number of Messier objects in the deep south. I'll just turn that on here. Around Scorpio and Sagittarius, below Ophiuchus. There are a number of Messier objects, nebulas and clusters and such. You can see with a telescope the Cat's Eye Nebula in Scorpio here, which is a globular cluster right near the very bright star Antares. It's a reddish, pinkish colored star. Antares is a rival of Mars, so it does have an appearance of Mars because of its color. It's a red supergiant. And over near Sagittarius, which never gets very high in the sky from our neck of the woods, there are a number of nebula to view. There's the Eagle Nebula, which is made famous by the Hubble Pillars of Creation picture that came out many years ago. And this is a Hubble image. This isn't what you're going to see in a telescope. It's going to, all this cloud, it's going to look kind of grayish green color. There's a very nice open cluster here, the wild duck cluster. It's an open cluster, and it looks, well, the people who named it thought it looked like a flock of ducks flying away. In terms of what's in the north, the Andromeda Galaxy, M31 is fairly low this time of year. M37, M38, and M36, some very nice open clusters in Aguirre de Charitier, the same constellation that bright star Capella resides in, are probably too low to the horizon to really make out. And of course, with perpetual twilight, the sky glow is kind kind of move from the northwest when the sun sets and move across the northern sky to the northeast, where the sun will come up again in the morning. If we look straight up, the Ursa Major, the Big Dipper, has moved away from the zenith. Of course, we follow the arc of the handle from the Dipper, or the tail of the bear, if you will, down to the very bright star Arcturus, which is the first star you're going to see at night when the sky gets dark. It's going to be the first star that pops into view. The summer triangle is rising a little higher each month to its position where it'll be almost directly overhead by the time the fall hits. And there are a few deep sky objects to see within its boundaries. Of course, again, these deep sky objects, you really do need a medium to large telescope to see them. There's the Ring Nebula in Lyra, and the Dumbbell Nebula, which is within the boundaries of the triangle. And just let me trigger the asterism box here. There we go. There's your summer triangle. So you've got your Dumbbell Nebula there. You got M29, nice open cluster here. Ring Nebula, which isn't within the triangle, but it's near the boundary. And then we have a nice globular cluster, M56. Again, all telescopic objects. I guess what I'm trying to say is the summer really isn't a good time for deep sky observing. But if you do have a telescope, there are things to see. Certainly, with a telescope, you would be able to see the great globular cluster in Hercules M13, and also M92. You can see those in a medium telescope, even in our perpetual twilight. So that's about all I got. We have very short nights in June. Of course, the solstice is in June. It's a point where the sun moves furthest north on its journey, and the official beginning of summer. Around the world, people have set up markers to mark the solstice. There's medicine wheels here in our own province, and of course, probably the most famous one of these markers is Stonehenge in England. So, which they set up to mark the solstice. It was a big calendar, and I understand that there was all sorts of events that would occur there. So, and people still gather at Stonehenge to mark the solstice. So, if you want to celebrate like the Druids did, I guess, you can get up on the 21st before the sun comes up and watch the sunrise furthest in the north. So I'll just play this little sunrise video here as the sun rises over Stonehenge. And that's it.
Are there any questions before we go on?
I was going to just mention, Jeff, that I think you could probably see Venus and Jupiter during the day.
Yeah, I was going to get to that, especially on the 26th, where the moon, once Venus comes, or once the sun comes up, Venus will be almost directly below the moon in a binocular field. And so if you can follow the moon into daylight, It'll be a waning crescent at the time, but you should be able, if you can find the moon, if you look below it, you could see Venus in the daytime in a pair of binoculars. And Jupiter, I didn't really think about Jupiter because Venus is just so much brighter. That's all. But yeah, you can see Jupiter in the daytime. I've seen Jupiter in the daytime.
That's because I noticed Jupiter and Mars were pretty close to one another. So I wondered if you'd actually be able to see Mars in the daytime as well. But you said the 26th was the time.
Yeah,
for
the
Venus?
26th, the moon will be above Venus.
Awesome.
Yeah.
Okay, thank you.
Okay, anything else? Okay, we'll move along to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon?
Okay, the first quarter moon will be on June the 7th. The full moon will be on the 14th, and it is known as the strawberry moon. It also has other names, the hot moon, the rose moon, and the last two, I presume because of its color, riding so low on the horizon, the mead moon and the honeymoon, because the moon looks kind of honey or mead colored in June. And then last quarter is on the, last quarter is on the 20th, and the moon is new on the 28th. Now, normally I pick out a feature from the RESC Explore the Moon certificate program, either the binocular or the telescopic program, but today I decided to do something a little bit different. And it's why I cringe when I hear the term supermoon. And that is a picture I took of a supermoon back in the winter. I guess because of the origin of the term, it was termed by an astrologer in 1976 to describe a full moon at or near perigee. And so, when I see astrologer giving names to stuff, I just kind of go, grind my teeth and chew on some glass. But it's certainly been picked up in the last few years by the media, and we hear the supermoon term all the time. In fact, right now we're in a midst of 3 supermoons in a row. And last month, in May, because there was also an eclipse, and it was a flower moon, which is a full moon in May, it was a super flower blood moon. And blood moon is a term I don't like either, but again, because of the guy that coined it as some TV evangelist, that annoys me. But anyway, the full moon, super moon, is on June the 14th. And then on July the 13th is the most super moon of the year. It's when the moon will be closest to the earth when it's full. So I guess that's a super duper moon. August 12th just barely misses out as a super moon. Now they call supermoons if they're around 360,000 kilometers from the earth. But August 12th is just outside that. And August 12th is right around the day of the Perseid, so we got a full moon to deal with for the Perseid meteor shower, so bad luck for us. So why do we have these things? If you're not confused already, like poor old Superman here and his bottle of Johnny Walker. It's because the moon's orbit is not round, it's elliptical, and it can vary from about 360,000 kilometers to about 405 kilometers from the Earth. The difference between a perigee, a moon at perigee and a moon at apogee is about 12% in size. So that would be about a 6% difference in size for an average moon, I guess. Now, only with accurate measuring instruments, or if you take photographs of a number of full moons and compare them, with the exact same equipment at the exact settings, can you actually see a difference. It's not really noticeable to the eye because there's nothing to judge it with. And yes, it is brighter. They know that because they can take light readings from it and say, yes, it is brighter when it is closer to the Earth. But when people say, oh, yes, it's very, very much brighter, they're comparing it to a memory, which I guess what I'm saying is when people say, oh, I really noticed it was brighter. Okay, sure you did. But what were you comparing it with? A memory from a moon last month or a year ago, whatever. But it does get people looking up, and I guess that's a good thing. Now, I have a little video here because I'm not going to finish with the moon just yet. Oh, and this is a picture I took, well, two pictures I took. One on July 26th in 2018 when the moon was at apogee, and then on March 19th, 2019 when it was at perigee. Just, yes, they are different, and I used identical equipment and cameras and such like that. So I have a little movie here for my next bit. A lovely oboe soundtrack. Boy, Tom Hanks was sure young 32 years ago. So we're going to talk about the moon illusion. And if you've ever done any traveling at night out in the country and we're lucky enough that the road happened to be pointing in the direction of either a rising or a setting moon, I'm sure you have thought, wow, is the moon ever big? It looks so big. Looks like I could just drive right up to it. Well, it is an illusion. Actually, when the moon is high in the sky, this chart shows how big the moon really is. And this chart shows how the moon is perceived, getting smaller and smaller as it gets higher and higher. But if you follow this line, you can see actually that the moon is actually further away when it's coming up or setting than it is when it's directly overhead. And you can prove this because I've done it myself, just for fun, is taking a picture of the moon when it's coming up. And when I take the picture, I'm thinking, wow, the moon is ever big. And then when I get the picture back, because I haven't done this recently, this is back in the days of film, it looks tiny, 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 tiny. The moon's diameter doesn't really change. It's accurate measuring instruments like those used for surveying or navigation shows the moon is no bigger on the horizon than when it's high in the sky. In ancient times, it was thought that this phenomenon was caused by refraction in the atmosphere. But it turns out it's all in your head. It's just the way we perceive stuff. Now, this picture here, with the moon on the horizon, and then the moon in the railway track. I admit, I'm looking at it right now, and this moon looks bigger than this moon, but they're actually the same size. It's the way we perceive stuff when the moon is near the horizon and there's objects in the foreground to compare it with, and it just makes it look bigger. And it also works for the sun, particularly if it's hazy, because I don't recommend staring into the sun. Someone would get the phone. And here's another illusion. Prove my point here. We have a larger disk here and a smaller disk here. The larger disk is surrounded by small dots. The smaller disk is surrounded by large dots. But if I make the dots disappear, they're actually the same size. So it's like I say, it's all in our heads. That's about all I've got to say about the moon illusion, except for you can create a moon illusion with photography, but what you need is a really long telephoto lens and have some people, as in this picture, stand directly where the moon is coming up, and you can get this moon silhouette feature. The telephoto lens makes the moon look big. It isn't because it happens to be coming up that it's looking big. So the moon illusion, it's all in our head. Normally I do a constellation section right now, but it's canceled due to perpetual twilight. I couldn't think of a good constellation that you could see much here with binoculars or naked eye. So I figured, well, I'll knock this back to July. So other highlights this month. Well, we've got the summer solstice on June the 21st. We're in noctilucent cloud season. In fact, one of our members who chases these things every year, reported his first confirmed sighting last night. And we got all-night satellites. I was talking to some of the guys before the meeting started about those who went out and looked for the meteor storm, on the night of the 30th and 31st. And I likewise was looking for a meteor storm. I saw a few meteors, but I did see a whole slug of satellites. And we have a daytime lunar X on June the 6th. So the summer solstice is the Earth is tilted on its axis 23 degrees. And on the 21st is when the northernmost part of our axis was pointed furthest toward the sun, which is why we get the summer here. That's why the ecliptic is low in the south. And it's also the longest hours of daylight of the year. And that occurs at 3:14 in the morning on the 21st of June. And this is a picture one of our members, Luca Van Zella, took. Well, actually, he made over a year, where he photographed where the sun was setting between the winter and the spring. So here it is setting in the winter, and then through the spring and the equinox, and then this is where it sets for the solstice, far in the northwest. And that is a result because the Earth's axis is tilted as we go around the sun. Noctilucent cloud season, the night shining clouds These are clouds very, very high up in the atmosphere, 60 to 80 kilometers up. The sun is just below the horizon from our point of view. We're in actually prime location to see noctilucent clouds. People in Toronto or in Halifax, they hardly ever see them. It has to be a spectacular display that climbs high in the sky for them to see them. But we can see them quite regularly just because of where we are on the planet. And that's me standing out in the field looking at a noctilucent cloud display last year. And this isn't out in the country. This is at the school field a couple blocks from my house. So, I mean, you don't have to get out of the city to see noctilucent clouds. You can see them in the city. What causes them? Excuse me. I've seen a lot of stuff where they say it's caused by meteor dust, but noctilucent clouds weren't really reported in Northern Europe until later in the 19th century. And meteor dust has always been in the atmosphere. You know, we're always getting meteors entering our atmosphere, breaking up and shedding dust. So I kind of doubt it's meteor dust. I think it's something else. And I'm thinking it's something we're doing. I think it's some sort of reaction to pollution. And here's a short little movie that one of our members put together. You can see the noctilucent clouds. They're an electric blue color. And regular atmospheric clouds are these dark ones here, backlit by the sky glow from this. And then you see some more regular clouds moving in, which will eventually block out the noctilucent clouds. And they do move. The clouds just aren't static. They do move over time. And the last one is just a little video time lapse I put together from my backyard. Just a shorty. Satellite time. This is the list of satellite passes, magnitude 3.5 or brighter, for Edmonton between 10:30 and midnight. And as you can see, there's quite a few of them. And I excluded the Starlink passes, otherwise the page would be quite a bit longer. From midnight to dawn, it's about 3 times as long as this page. We're in prime satellite time because the sun is below the horizon, just below the horizon, and the satellites are above and they are still in sunlight. And that's why we can see them, because the sunlight is lighting up these satellites. So, and there's small ones, there's bright ones, there's pieces of rockets. I like to think that very bright ones coming on a north to south trajectory or south to north trajectory are probably spy satellites, because I know they're quite big, and so they would be bright, and they do travel north to south for the most part, so they can map the whole Earth in one day. And that's just a short exposure. I think it was about 15 seconds of the space station coming over that streak there. And we do have a daytime Lunar X. All the Lunar X's this year going forward are going to happen in the daytime. And the Lunar X is it's the shadowy, it's right there. I don't know if you can see it, it's right there. Sunlight shining on the top of craters on the moon. It only lasts about 4 hours, which is why you don't see it every month. And there it is there. And this was just some pictures I took a few months ago when we had our last daytime Lunar X. And I have to say, visually, it's a lot more obvious than this picture shows. I had no trouble spotting it. looking at it through my telescope, but trying to see it through my camera was a bit of a chore. So anyway. So June the 6th, starting approximately 3:15 in the afternoon. If you have a telescope, you can look for the Lunar X. Okay. Okay, this is our little thing I do every month. What happened this month in space history? And it isn't just anything in June, it's a June whose year is divisible by 5 with our year. So a year that ends in 2 or ends in 7. Oops. So I have another video, a montage before that kind of relates to what we're going to talk about.
Mr. Crusher, ready a collision course with the Borg ship.
Ramming speed! Ramming speed! We're going to be rammed!
Okay, and if you're interested, those clips were from Star Trek Next Generation Best of Both Worlds Part 2, Ben-Hur, PT-109, The Battle of Britain, A Night to Remember, Memphis Belle, and then back to Ben-Hur. So what's all this got to do with space? Well, before we get to the historical item, we'll talk about the first modular space station, the space station Mir. Mir, its core module, was launched in 1986 by the Soviet Union. It was expected to operate about 5 years, but it actually was in space for 15. It was eventually deorbited in 2001, and it was made up of 6 modules, each launched separately. There was the core module, this green one, Cavant 2, onto the back here. The Cavant module was also used on the Salyut space stations also as an extra additional space and science. Okay, there was Cavant 2. There was also Cavant 1, or pardon me, Cavant 2, Cavant 1, Cavant 2. Sorry. There was the Crystal module, this red one here. And then there was the Spectre module, this guy here, the gray one. And then this orangey colored thing, which was the last module, and it was Piroda. And that's a picture of the Mir space station in space. And it's quite a strange looking object in space. 4 of the modules were joined to the core module through a central node. And this is an interior of that central node. And ask you to remember this picture because it's going to come up here in a little bit. 2 of the modules, Spectre and Piroda, were actually paid for by the United States after the Soviet Union collapsed. The newly formed Russian Space Agency didn't really have a lot of money on hand. And the United States feared that some highly trained and extremely smart Russian scientists might go end up working for places that the United States didn't really want them to, like North Korea or Iran. So they paid for 2 of the modules and also paid to keep Mir operating as part of the Shuttle Mir program, which would give their astronauts NASA astronauts a chance to live aboard a space station in preparation for the eventual launch of the International Space Station, which the first part went up in 2001. It was normally occupied by a 3-person crew, although during crew changeover, there would be 6 on board, or if a shuttle docked to it, there could be as many as 10 people aboard this thing. It was extremely crowded inside, with equipment scattered all over the place. It was on the floor, on the ceilings. It was very, very small. When you see the astronauts aboard the International Space Station, it's quite spacious, but Mir was very crowded, as you can see here. It kind of reminded me, looking at these pictures, of the inside of a World War II bomber. I like air shows, and if there's a tour of a bomber, I always like to go inside. And there's not a lot of room in there, particularly inside the Lancaster, which was a mid-wing bomber, and it had a huge wing spar that ran right across the cabin between the cockpit and the front, where the navigator, bombardier, pilot sat, and the back door, which they would need to get out of if the plane was going down. The station was showing its age, and it was estimated near the end of its life the crew was spending more than half their time fixing stuff. And there was a major fire aboard Mir in February '97 while a NASA astronaut was aboard for a long duration flight. So, which brings us to June 25th, 1997. And this is a picture from a Progress spacecraft. The Russians used, or the Soviets used, what was known as the Kurs automatic docking system. It had been used for years on the Soyuz and Progress supply ships. And a variant of this is still used today to dock spacecraft, either the manned Soyuz or the Progress cargo ships, to Mir. And the Kurs system was actually built in the Ukraine, and when the Soviet Union broke up, the Russian Space Agency, short of money, didn't want to have to pay a now foreign company $2 million per spacecraft for Kurs. So they developed a system called Toryu, which is a Russian acronym which roughly translates to teleoperated mode of spacecraft control, where the crew aboard Mir would manually fly Progress in for a docking by remote control using 2 joysticks and a monitor with a view from Progress. And this monitor is actually showing the view from Progress, and there you can see the Mir on the monitor. It was almost like a video game. Now, in June of '97, a Progress M34 had docked with Mir, they've unloaded its supplies, and they had docked using the Kurs system, but they wanted to try this Toryu system out to redock it. So they separated the Progress, flew it off a little bit, and then tried to fly it in and dock. But first attempt failed because they lost the signal for the camera, so the guy flying it could see what he was doing from Progress, and it was determined later that the radar on the Progress, which is part of the Kurs system, was disrupting the signal. So what they did on June the 25th, with Progress moved away, they turned the radar off and just tried to fly it in manually or visually using the monitor with no information onto how far it was from the station and how fast it was going. And the cosmonaut flying it was trying to steer the craft toward the docking ring. And he asked the other 2 crew members, one of them was another NASA astronaut who was staying for a long duration flight. His name was Michael Foale. He was British born, but he was an American citizen. To visually track Progress and use laser rangefinders out the window to determine the distance, and then with stopwatches to determine how fast Progress was going. However, if you remember the picture of the space station in space, it's got a lot of stuff sticking out the side, solar panels and radiators and such. And they couldn't actually see progress until it was only about 150 meters away. So the pilot fired braking rockets, but they didn't slow down the craft enough, and it collided with the station, damaging the solar panels. And then it bounced off the panels and hit the Spectre module and breached the skin and then floated off. And the collision also sent Mir into a tumble that caused it to eventually lose most of its power as its solar panels were no longer facing the sun. So this is a view of some of the damage to one of the solar panels that got hit. You see a big hole in it, and it's torn away from its mate there. And that's another picture showing the Spectre module. This was taken months later, so you couldn't. There's no venting or anything. The thing was a complete vacuum by then. The atmosphere vented out completely from Spectre. So as soon as it hit, there were alarms because the station was starting to depressurize, and so they determined that yes, it was the Spectre module that was causing the problem. So they had to close the hatch between the Spectre module and the rest of the station. Otherwise, they would lose all their atmosphere. Now, if you remember that picture of the nodes with all that hoses and cabling and stuff running into the various modules, well, they had to get rid of all that. So here's another picture just to refresh your memory. There was cables and hoses and stuff running into the module, and they had to very quickly disconnect and pull out the hoses, in some case cutting them, to get the hatch to close. So they eventually did get the hatch to close and sealed the leak. They did attempt to fix it later in external spacewalks, but they couldn't actually see where exactly the crack was. So Spectre was never used again. And as I mentioned, Spectre was one of the modules paid for by the United States. And when American guest astronauts would stay for long durations, they would work in the Spectre module. That's where all their experiments were. And it was also where their bed was and all their personal effects. So Michael Foale lost any personal items he brought up with him, and all the experiments, all the American experiments were lost because they were sealed inside this module, and they couldn't get at it anymore. This station, as I say, was tumbling, losing power, and it took a lot of work by the crew and the ground controllers to eventually restore Mir to operation. The Toryuu system was used on later missions with a working radar, but the Coors automated system is what is used today. I imagine the Russians built their own, back engineered what they were getting from the Ukraine. I can't see them, especially now, buying parts from Ukraine. So this was the first and so far only time a crewed spacecraft had been involved with a collision with another spacecraft. And the last thing is a little excerpt from a documentary from the BBC. And I'll just play that.
Things had gone wrong, very badly wrong. The range and the speed had been horribly misjudged.
Когда я видел, что станция набегает очень быстро, то есть эта скорость я не ожидал, почему она так летит. Я чувствую, что как будто нет торможения. То есть я торможу, а торможения нет.
Смотрю, как этот грузовик проносится под нами, прямо здесь под иллюминатором.
Sasha looked extremely agitated, stood up and, well, came erect and said, "Michael, в корабль, to the spacecraft."
Я говорю, Майкл, в корабль. Майкл отсюда полетел туда.
That order that Sasha gave me, в корабль, don't stay and try and help us, don't let us use your expertise, don't let us do anything with you, just get out of our way to the spacecraft.
Не хватило тормозного пути, не хватило времени для того, чтобы этот грузовик увезти от станции.
Ну, он мне акулу напомнил. Грозный. Я вижу, как вот это вот черное тело с этим вкраплением проносится подо мной. Я прищуриваюсь. И в это время, значит, мощный такой удар потрясает станцию.
I felt through my fingers a shudder, a thump on the station, and I heard what seemed to be far off, a ka-thump. At that point, I knew we had been hit by the Progress.
И сразу сработала сигнализация, разгерм станции, начало падать давление и началась закрутка станции.
So that is that. I always like to reference Heavens Above. It's a great site. It's got finder charts for comets. It has finder charts for, or charts that'll show the track of satellites from that chart I showed you earlier. If you click on it, it'll give you a map of the sky. You have to put your location in first, of course, and show you the track the satellite will take across the sky. It's a great source. Next What's Up is on June the 29th, just because there's 5 weeks in June. I figured let's do this on the 29th rather than on July the 6th, and possibly miss a few things at the beginning of the month. Our next meeting of the RASC, our final meeting before our summer break, is on June the 13th. It's a members night. So members will be making various presentations. I believe one of our senior members is going to continue a series he started a few months ago on the history of our Edmonton Center. And Alistair does introduction to stargazing on Wednesday. And why did I put May 22nd? Jeez, it should be June 22nd. Sorry about that. And all these times are at 7:30 Mountain Daylight Time. And with that, I'll say thank you. And if there are any questions, I will try and answer them now.
Thank you very much. I thought rather than typing something out, can you hear me okay?
Yeah.
Awesome. Thank you. So the Progress ship that collided with the Mir space station, first of all, that's an absolutely chilling story. I'd never heard of that one, but can you imagine being in that group and going, oh boy, right?
Yeah.
But the Progress ship looks a lot like a Soyuz capsule. Are they built sort of on the same system?
Yep. Yeah, they're very similar. They don't. They're just basically a cargo carrier. They are built like a Soyuz. They're launched on a Soyuz rocket. Although the only difference if you saw them launch is the Progress doesn't have an escape system.
Oh, sure, because it's just cargo.
It's just cargo.
Right.
Yeah, it's slightly shaped a little bit different. If you saw them side by side, they are shaped different. There's no life support system on board, and
right,
no controls and stuff like that. Yeah.
So
it's based on Soyuz for sure.
Okay. So when the shuttle wasn't running and they were using Soyuz to get people up to the ISS, basically it plunks on top of some sort of Soviet rocket.
Yeah, the R-7.
Okay, and you stuff people inside of it.
That's right.
Up they go, and it docks at the ISS. But the Soyuz has this, it's like rather elongated. It's got some solar fins out of it, etc. But that's not the entire crew space, I'm assuming.
Oh, well, hang on a sec. I will illustrate here. Hang on.
Okay.
I just have to get this out of the way.
And
let's see, where can I put this? I can put that there.
Okay.
Okay. And okay.
And
and I
Go ahead.
flipped on my camera, but apologies. A couple of your other victims for the night, quote unquote victims, disappeared already. I hope I didn't jump in or jump the queue or anything like that.
No. I guess maybe they were watching a hockey game. So among other things, besides astronomy, I also like to build models, and I do build models of spacecraft. So here, this is 3 Soviet era spacecraft, and the Soyuz is in the front here.
Okay.
So let's see if I can take it off its stand. There we go.
Okay.
Okay, so here's Soyuz. And it's 3 parts. There's the service module here on the back. There's the orbital module, this egg-shaped thing on the front, and then there's this bell-shaped thing in the middle, and that's where the crew sits. That's the only part that comes back.
Oh, okay.
And they are literally stuffed in there. It's pretty tight quarters in that thing.
Wild.
So all the docking equipment is on the front here. There's
that's your
the radar and stuff, and the solar panels. All the rocket motors are in the back here, solar panels, etc.
Okay.
So when the mission is done, this back part from about here back comes off. This part on the front comes off, and the only thing that comes in is this bell-shaped thing. That's where the crew is.
Okay, so the solar panel the solar panel section and the rockets at the bottom burns up on re-entry. And it's not heat shielded or recovered. And then the very front attachment nodule, same thing. So the crew is in the middle bell, protected, and they land in Kazakhstan and go drink their vodka. That's
right.
Weird.
Yeah, they've been using that same spacecraft since the first flight was in 1967.
God.
It's very much well, mind you, the first flight didn't go so well. The pilot was killed, but after they fixed it, it's very successful. They did have one other fatality in 1971, where the re-entry module decompressed while still in space.
Oh boy!
A valve popped open, and the crew was killed there. But it's a very safe spacecraft. It's very reliable, and they constantly improved it.
Yeah.
I mean, with modern electronics and stuff like that. Because there was a time after the decompression flight, because it's so cramped, they would send them up without spacesuits because, you couldn't get 3 guys in a spacesuit in this thing.
Oh.
So they didn't wear spacesuits, which is why they died when it decompressed. So for the longest time, they flew just 2 men up to their space stations, and then with better electronics, they got more smaller stuff. I guess they stopped using tubes. And
that's a real step forward.
And they could get 3 guys back in there wearing spacesuits. So
interesting. Okay. So when that unit detaches from the ISS, all 3 components detach.
Yeah. Oh, yeah.
And then it starts its re-entry, or before then, it kicks away the pieces they don't need.
Well, they fire the rockets to deorbit, and then they because the rockets are all in the service module. If they detach that first, they'd be stuck up there.
They'd be stuck. Yeah, exactly. Yeah.
So after the deorbit burn, that's when everything separates.
Wow. It seems very wasteful because you're losing a lot of stuff each time. But I guess I'm comparing it to something like a modern SpaceX Crew Dragon capsule, which is looking, the thing is the bloody lap of luxury, and they got their fancy spacesuits and they got their big screen TVs.
Yeah.
But on something like the Crew Dragon, that whole capsule comes back. There's it's what attaches, and that whole thing comes back. Well, it's got to have some thrusters and stuff on it, right?
Yeah. Well, they do jettison the back part, the part where the solar panels and stuff are.
Huh.
Yeah.
On the Crew Dragon as well.
On the Crew Dragon. Yeah. And the same with the Starliner. There's a service module there that they have to jettison also.
Okay. So I guess
there are thrusters on the re-entry portion to control it coming through the atmosphere.
Right.
Yeah.
So basically the physics of the whole situation, et cetera, require that the crew capsules have some sort of independent thrusting and and electronics, etc., and that doesn't come back with you. But in order to successfully get up and bind with the ISS, you got to have some. You're not just floating free. You've got to have some control, some power.
Oh yeah.
Thrusters and all that.
You need rockets and stuff. Yeah.
Yeah.
The only thrusters are on the return section is just to control attitude.
Right. Huh.
Make sure you're pointed in the right direction and all that stuff. So.
My goodness. Well, never doubt that the Russians can't do anything. That they have a reputation for being absolutely crazy, and now I can see where some of that reputation comes from.
Well, it works. I mean, like the R-7 rocket is this that they use to launch Soyuz. It has a different upper stage but it's the same rocket that launched Sputnik. It's the same rocket that launched Vostok, Voskhod, with different upper stages. Well, Sputnik didn't have an upper stage. It just sat on the very top of the rocket and went up. But yeah, it's the same friggin' rocket that they first flew in 1956.
Wow. But the core design is still the same after all those years.
Yep. Mm-hmm.
Oh my God, that's just crazy.
Very reliable. Very reliable.
Yeah, clearly. I mean, evolution dictates that if it's not reliable and doesn't work and doesn't survive in the niche, it's going to get changed or adapted or eliminated.
Yeah.
And
it's very much, very much if it ain't broke, don't fix it.
That's funny. Wow. But yeah, I'd never heard of that whole Mir accident because they could have lost the entire. I mean, that could easily have turned out a lot worse.
Oh yeah, absolutely.
Yeah. Huh.
And then 25 years ago.
Wow, that's crazy. And then, of course, there's no technical reason why these space stations can't just keep going and going and going. Like you said, Mir had a lot of repairs needed, and etc. But you keep throwing repairs at it and keep throwing extra thrust at it to get it back up as it sort of drag, because these will all drag a little bit in the extreme upper atmosphere and sort of slowly over time lose velocity, right?
Yeah, it will get dragged. Yeah, it's just equipment breaks down. I mean, nothing lasts forever. I mean, already parts of the original space station are, over 20 years old.
Yeah.
I mean, stuff wears out.
Yeah, and you are in a harsh environment too, right?
Well, yeah. But it's like anything. It's like an old car. Eventually, you got to say, do I want to pour more money into this, or am I going to take it out to the field and shoot it?
Exactly, and be done with it.
And eventually, they'll say enough's enough with the ISS, and they'll dump it into the Pacific, like they did with Mir.
Yeah, exactly. And then, of course, Skylab was the U.S. version of a space station, but not nearly as big as Mir, from what I remember.
No, it was a converted third stage from a Saturn V. They had hoped to be able to use it in the shuttle program, but the sun was extremely active in the last part of the 70s and expanded the Earth's atmosphere, and there was more drag than they expected.
Wow.
And it was re-entered in July of 79.
Right. Huh. Yeah, so Skylab by comparison was teeny tiny, like not even close to the same size.
Well, it was pretty big compared to, but it was one piece. I mean, Mir is modularized. I mean, as is the ISS. They send out little pieces at a time.
Right.
Where Skylab was just one big honking space station.
Right. Yeah. It reminds me of the idea that people have where they convert sea cans into apartments.
Yeah.
Same kind of idea, right? Like convert a chunk of the Saturn V and put a couch in it, and you've got a space station. Cool. Neat. Well, I'll have to do some reading on that whole Mir thing. That's a bit of an oh crap moment for sure when that would happen. And again, talk about just being like, we'll be fine. We'll guide it in once we see it. We'll guide it in, and who needs radar and that kind of stuff. It's just really, flying by the seat of your pants, literally.
Well, they were very cash strapped back then. They're still cash strapped.
Yeah. But, and of course, the whole political thing that's going on right now, Russia, Ukraine, that's not going to help. I don't know, maybe the scientific community will be a little less politicized, but that's got to be putting a pile of strain on stuff right now.
Sure. Well, I mean, like the motors for the American Atlas V are actually made in Russia.
Yeah, a friend of mine who's a big NASA space fan mentioned that the other day. I was like, really? So that's gotta, because wasn't it Blue Origins was supposed to be the company that was gonna get the new engine going for that, but they haven't delivered anything.
Yeah, they haven't delivered anything yet.
Yeah,
which is amazing considering it's Amazon. They couldn't deliver.
Ching.
Cha-ching. Yeah, I need a drum roll.
Yeah, exactly.
Or a rim shot.
Yeah. And of course, now the U.S. system can tap into the whole SpaceX program to get people up and back. I mean, they're all certified.
Oh yeah, they've got the Crew Dragon, and then the Boeing one worked okay, so they'll next fly that with people, and then they'll have two options if something goes wrong with the other one. Right. In fact, the Russians have actually contracted to fly on a Crew Dragon to get one of their guys up there. So
interesting. So the tables are reversing now to an extent. Yeah. Interesting. Wow, very cool. Good. Well, the history, the what happened in the space section is, I mean, everybody does great talks, you included, of course, but I always look forward to the history section. That one's kind of neat. Yeah,
thank you.
That's a good spot. Cool. Well, thank you very much. I'll get out of your way and
thanks for joining us.
Yeah, absolutely. No,
we'll see you again sometime.
Absolutely, and it's much appreciated and a very nice distraction from the real world. So thank you very much.
Okay. All right.
All right.
Okay. Thank you.
Thanks, guys.
There, Jeff.
Care.
Yeah.
See ya.
Okay. See you, Jay.
Yeah. See you later.
Thanks for sitting in on me or with me. So.
Yeah, always a pleasure, man. It's pretty fun, actually. So.
Yeah. Okay. Yeah. I'll edit out the coughs and stuff, and I'll put it on YouTube in a couple days. Or so.
Yeah. Feel better soon, eh?
I hope so. I thought, oh my God, I got COVID, but no, I've tested 3 times and nothing. It's I just got a cold or allergies or something. I don't know.
Yeah. Alrighty. Well, good luck with all that.
Yeah. Thank you.
All right.
Take care, guys.
Good night.
Ciao.